Here's the game plan for today. We'll kick things off with biology and the mechanics of life, shift gears into chemistry, tackle physics, and then wrap the whole shebang up with logic and language.
All right, Section 1, Biology, the Mechanics of Life. Let's do it.
Take a look at this first question. A DNA molecule contains 30% adenine. The percentage of cytosine is A, 20%, B, 30%, C, 40%, or D, 70%. Now, at first glance, if you're feeling rusty on your molecular biology rules, you might be tempted to just guess. But let's look at the math here. Okay, so this is actually a pretty straightforward puzzle once you see it. DNA base pairs are super loyal, right? They always match up in a specific way. Adenine always pairs with thymine. So if we've got 30% adenine, we absolutely must have exactly 30% thymine. That's 60% of the whole molecule right there. Subtract that from 100, and we're left with 40%. Now, guanine and cytosine are the other pair, so they have to split that leftover 40% right down the middle. Half of 40 is 20, meaning cytosine is exactly 20%. Boom, option A. No wild guessing, just pure structural logic. Moving right along to our next biology challenge. Which enzyme joins Okazaki fragments during DNA replication? A, DNA polymerase I, B, DNA ligase, C, helicase, or D, primase. This one is straight up testing your precise knowledge of cellular machinery. You really need to know what job each of these microscopic workers is doing on the factory floor. And the correct answer is DNA ligase. I always like to think of ligase as molecular glue. You know, helicase is out there unzipping the DNA, and primase is setting the starting line. But it's specifically DNA ligase that swoops in to seal the gaps between those newly synthesized Okazaki fragments. It stitches them into one continuous, seamless strand. That makes option B the undisputed right choice.
Section 2, Chemistry, Reactions, and Rules.
Check out this wonderfully tricky pH question. The pH of a solution changes from 4 to 2. The concentration of hydrogen ions becomes A 2 times, B 10 times, C 100 times, or D 1,000 times. It's so easy for human intuition to look at a change from 4 to 2 and think, difference of 2, so it's just 2 times. Please do not fall for that trap.
The real answer is 100. So the absolute key here is remembering that the pH scale is logarithmic. It's not linear. Every single whole number drop on that scale is actually a 10-fold increase in hydrogen ion concentration. So dropping from 4 to 3, that's 10 times. Dropping from 3 down to 2, that's another 10 times. And 10 times 10 gives you a massive 100-fold increase in acidity. Option C is your correct answer.
Let's level up the math just a bit with some oxidation numbers. The question asks, the oxidation number of chromium in K2Cr2O7 is A plus 3, B plus 4, C plus 6, or D plus 7. To nail this, we just have to systematically break the chemical compound down into its pieces.
This maps it out perfectly for us. The golden rule is that a neutral compound has to net out to a charge of exactly 0. Potassium is a group 1 alkali metal, meaning it's always plus 1. We have 2 of them, so that's a total of plus 2. Oxygen, almost always negative 2. And we have 7 of those, which gives us a hefty negative 14. So to balance a plus 2 and a negative 14 back to 0, the chromium part of the molecule has to equal plus 12. But wait, look super closely at the formula. There are 2 chromium atoms, Cr2. So we divide that plus 12 by 2, meaning a single chromium atom has an oxidation state of plus 6. Option C is the winner.
Section 3, Physics, Forces, and Wanes.
I absolutely love this question. A body moves with constant speed in a circular path. Which quantity continuously changes? A, mass, B, velocity, C, speed, or D, kinetic energy? The test makers are totally trying to play mind games with you here. That phrase, constant speed, is a very clever distractor, trying to lull you into making a mistake. But remember your basic definitions. Velocity is a vector quantity. That means it cares about both the speed of an object and its exact direction in motion. So even though the speed is perfectly locked in as it goes around that circular path, the object is constantly curving. Its direction is continuously changing at every single millisecond. And because the direction changes, the velocity is the quantity that continuously changes. Option B is correct.
Next up, let's look at a foundational wave mechanics question. If the frequency of a wave doubles while its speed remains constant, its wavelength becomes A, double, B, half, C, 4 times, or D, unchanged. This whole thing hinges on knowing how the components of a wave talk to each other. It's a direct trade-off. The formula for wave speed is velocity equals frequency times wavelength. If the speed on the left side of that equation stays exactly the same, but the frequency on the right side suddenly doubles, well, the wavelength literally has to do the exact opposite to keep the math balanced. They are inversely proportional. So if frequency doubles, the wavelength has to become half. Option B is the only logically sound answer here.
Section 4. Logic and language. Almost there.
Take a hard look at this sequence. Find the next number in the series. 3, 7, 15, 31, 63. What comes next? Is it A, 95, B, 127, C, 125, or D, 129? I'll give you a second. Try looking at the gaps between these numbers to see if you can spot the hidden pattern. Let's map it out step by step. The jump from 3 to 7 is plus 4. From 7 to 15 is plus 8. 15 to 31 is plus 16. Do you see it now? The amount we're adding is doubling every single time. 4, 8, 16, 32, which means the next logical jump has to be plus 64. If we take 63 and add 64 to it, we effortlessly land on 127. That makes option B our answer. Okay, grammar time. Choose the correct sentence. A, neither of the boys have completed the assignment, or B, neither of the boys has completed the assignment. This is tricky. The real trap here is all about how we treat that often misused word, neither. So the rule to remember is that the word neither is singular. It essentially translates to not one and not the other. And because it's singular, it demands a singular verb. You wouldn't walk around saying he have completed, right? You'd say he has completed. By that exact same logic, neither of the boys has completed the assignment is the proper English construction. Option B is correct for sure. Well, we have covered a serious amount of ground today. Let's bring this all home. Acing this exam isn't just about surviving a grueling test day. It's about fundamentally mastering these underlying concepts. I want to quickly recall something like Avogadro's law. It states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. I love this because it's a beautiful reminder that foundational, totally predictable scientific principles govern absolutely everything. There is an order to all this chaos. Which brings me to my final question for you today. When you're sitting there studying, will you rely on just rote memorization, like blindly trying to memorize that pH 2 is 100 times stronger than pH 4? Or will you commit to mastering the underlying logic of the universe? When you actually understand the why behind the science, the right answers on the test simply reveal themselves. Keep studying, keep asking why, and we'll see you in the next explainer.